Okay, see the problem based on deBroglie's theory, nothing but deBroglie's equation. Here in this problem, the deBroglie's wavelength. So we need to calculate the deBroglie's wavelength, which is associated with a ball of mass 200 grams and is moving with at a speed of 5 meters per hour. Generally, the velocity must be given in second in this equation, but here it is given 5 meters per hour is in the range of, means we need to calculate the range of deBroglie's wavelength. It is simply normal formula. It is lambda is equal to h by mv. So lambda is equal to h value, we know that in terms of joule into second, mass. We are following the SI method, that's why it must be, mass must be in kgs. Next, velocity. So velocity must be in meters per second, but here it is given as 5 meters per hour. Means we need to get velocity in meters. As we are following the SI method, it must be in meters per second, but here it is given in hours. So hour means so we need to change this 5 meter per hour into second. So we need to convert into per second, and 1 second now how much distance it travels. Sorry, find out value. So hour means how many seconds? 60 minutes and 60. In 60 into 60 seconds, it travels 5 meters. So what about in 1 second? And here upon this calculation, approximately we get means in 1 second, it travels 0.0014. Means what is its velocity? Velocity we can write 0.0014 meter per second. Okay, we can directly write now. It's 200. Let's make it 2 into. It is 0.14 into 10 power minus 3. Into 14 is become 10 power minus 2 to the power of minus 5, and here we get the lambda is equal to, so your 6.625 divided 28, approximately we get 0.2366 34. So finally we will get and the lambda is in the range of 30 meters. So just using the direct formula, lambda is equal to h by mv. There is no simple one, but what is the difference in this is only the speed is nothing but speed, nothing but we can take it as velocity in terms of 5 meters per hour. Thus we modified it into per second, then substitute in this equation, directly we will get the answer. Okay. Okay, see the second one. So again we need to calculate the deBroglie wavelength of a particle having the momentum 3.3 into 10 power minus 24 kg meter per second. Same, we need to calculate the deBroglie's wavelength. So lambda is equal to h by mv. So here mass velocity is combined, we will say it as momentum, that is equal lambda is equal to h by p. We need to calculate this lambda, just directly substitute these values. This is all into second. The momentum is given as minus 24 kg meter per second. Here the units are important. The lambda, this is approximately, we can take it simply 2. Minus 24 plus 24, it becomes minus 10. So meters, as we are calculating total in SI method, so lambda must be in meters. So here important one is how you got this meters if the values are like this. So joule into, in the place of joule into second, actually we can write kg meter square second inverse. By expanding this joule and making into second, we will get kg meter square per second, and it is given kg meter per second. So finally we will get meters. Okay, and always doing this type of problems, so we must take care of the units. As we are following SI method, total values must be in SI method. If you follow the CGS method, means if you follow the erg into second, the CGS method, the follow the all values must be in a CGS method. Okay, take it. Okay, see the next one. So find the deBroglie's wavelength. Again, we need to calculate the deBroglie wavelength of a bullet coming out from a rifle. Mass having just 2 grams, moving with the speed of 2 meters per second. So direct one, lambda is equal to h by mv. So what is the h value? We know that. What is the mass? So as we are taking this in joules into second, so it must be in kgs. And the velocity already given in meters per second, no change in it. So here 6.625 by 4 approximately we will get 1.66. So finally the lambda is 1.66 into 10 to the power of minus 31 meters. As we are following total SI method, lambda must be in meters. Okay, so simple one. Just remember this formula for all these calculations and take care of units. Okay, see the next problem. Here, if wavelength of an electron is 5 angstrom, here wavelength is given, so we need to find the velocity of that electron. We need to find the velocity of that electron. So the wavelength is given, velocity. So what is the relation between that wavelength and velocity? We know the relation is lambda is equal to h by mv. So the lambda is given, we need to find the velocity. So what is v now? H by m lambda. Here mass is directly not given. So given the particle is electron, so we must know the mass of electron in terms of kgs here. Lambda is again 5 angstroms, so it must be in meters. So here we get so by multiplying this we will get approximate 31, here this is 41, and on this calculation we will get 0.145. So generally we make it as 6 meters per second. So sometimes it may be given in terms of centimeters. So just we are calculating total in essay method. But sometimes if you take the multiple choice answers, there may not be 1.45 into 10 power 6 meters per second. The value may be in the centimeters. Thus we need to convert into meters and becomes centimeters per second. Okay, take it. So here we need to find the momentum of a photon having frequency. When photon means we know it is a light particle. The light particle is having wave nature and the particles are having the frequency 10 power 15 second inverse. But we need to find the momentum. So already we know the relation for momentum is lambda is equal to h by p. Say it is equation 1. So we need to calculate the momentum p. So to calculate the momentum p, we must know about the lambda. We must know about this lambda. So what is the value of information given is frequency. The frequency is given 10 power 15 second inverse. So with the help of the frequency, we can calculate the lambda. Then substitute in equation 1. So what is the frequency and wavelength relation? We know nu is equals c by lambda. We need to get lambda, so that is lambda is equals c by nu. What is c? C means the speed of light, we know that. Right. What is the frequency? 10 power 15. So here we get 3 into 10 to the power of minus 7 meters. Means lambda is 3 into 10 power minus 7 meters. So by substituting in equation 1, the P is equal to h by lambda, h value 6.625 into 10 power minus 34 joule into second. The lambda as we calculated here with the help of this formula, minus 27. So this value approximately gives the finally we will get what will be the units for momentum? So momentum here totally we followed the SI method. Means momentum means mass into value. So we are following SI method. So mass is in kgs, velocity in meters per second. Okay. So this is the just making two formulas connection. Okay, right on. You must take these problems in notes. So here it is given that the wavelength of the electron is numerically equal to the distance travelled by it in 1 second. So distance travelled by in 1 second means it is nothing but equal to velocity. It is nothing but equal to its velocity. So velocity is here equal to lambda. So what is the lambda? It is in terms of formula order, not a numerical formula. We know the general equation lambda is equal to h by mv. Here it is given that as velocity is equal to lambda, in the place of velocity we can write lambda by changing it to lambda square equal h by m, and finally we can write lambda square. So lambda is equal to root h by m. So this is also useful in some type of problems where the velocity is equal to lambda. If the velocity is exactly equal to its wavelength, then directly we can write lambda is equal to root h by m, where m indicates the mass of that particle. Okay. Here again the similar problem. Find the de Broglie wavelength which is associated with a particle having mass 1 milligram, having 1 meters per second velocity. Thus here take care of units. We know the lambda is equal to h by mv. We know the h value, Planck's constant, joule per second. What is the mass? Here it is given 1 milligram. So here it is given in 1 milligram means we must convert it into kilograms. So here the mass is given as milligrams. So we need to change it into kgs. So 1 milligram is how many kgs? Approximately 10 power minus 6 kilograms. Okay. 6. What is the velocity? Is 1. So simply here we get lambda equals is 28 meters. So this is the de Broglie's wave equation problems. Somewhat very easy problems. We will provide you worksheet on these problems. So tomorrow you will get the worksheets on photoelectric effect problems and the de Broglie wavelength equation problems. Okay.